Hi and welcome back guys. In this video we will do an example related to X square test. So the question says a die is thrown 276 times and the result of these throws are given in the table. So we are given a particular table. In the first row of the table it is tabulated all the possible numbers when we throw a die. In the second row we are given frequency, that is number of time particular number appears. So when we throw a die 276 times, number 1 appears 40 times, number 2 appears 32 times, so on and so forth. And we have to test whether the die is biased or not. And we are given a particular value x square at 5% level of significance, and for 5 degree of freedom is 11.09. So guys, we will use this particular value in our calculation. Now we will do this whole example in total 6 steps. So first step is null hypothesis. It says that the die is unbiased. The die is unbiased. And if this doesn't work, then we will apply alternate hypothesis. It says that die is biased. The die is biased. Then after we will assume the level of significance. Now in this example, level of significance is already given, that is 5%. So alpha will be 0.05. But if this value is not given in the question, then we will assume, and always assume 0.05. But in this case it is given. So we will write given. Now we will move on to the fourth step. That will be test of statistic. Test statistic. Now in this test, we will first calculate expected frequency for each number. Now we are throwing our die total 276 times, and there are total 6 number that can be possible. So total number is 6. So on an average, each number appears 46 times. So our expected frequency is 42. Here Fe is expected frequency. Now we will create a table. So we will create a table of total 4 columns. In first column we will write all the possible numbers. So number obtained. Then after we will write observed frequency, that is FO. Then expected frequency, third column is expected frequency, that is FE. And finally in the fourth column we will calculate FO minus FE square. We will take difference of these two columns and square them up, and then we will divide by value of Fe. So that will be our fourth column. So number of 10. Then here we will write all the possible numbers when we throw a dice. So 1, 2, 3, 4, 5 and 6. Total these 6 number can be possible. Here observed frequency, that is we are given in the question. Number 1 appears 40 times, 32, 29, 59, number 5 57 times, and number 6 59 times. Then we will write expected frequency that we had already calculated. It will be 46 for each numbers. So on average each number appears 46 times. If you add all these numbers, then you will get 276. Now you have to subtract these two numbers. You have to take difference of these two numbers, and you have to take square of this difference. So 40 minus 46, that is 6. So 6 square divided by FE. FE is 46. So if you divide 36 by 46, you will get 0.78. Now likewise you have to calculate whole this column. So you will get all these datas: 3.67, 2.63, and finally 3.67. Now you have to sum all this number. You have to take sum of all these numbers, and you will get x square as 21.29. So our x square value is 21.29. Now we will move to step number 4, that is critical values. Step number 5 says critical values. So first we'll calculate degree of freedom. It is n minus 1. So total 6 numbers, n is equal to 6, and 6 minus 1 is 5. So we have 5 degrees of freedom. And for 5 degrees of freedom and 5% level of significance, for v is equal to 5, x square value is given as 11.09. Now this value is less than this value of x square that we have calculated. So we will write our decision step, that is last step. Since x square is greater than x square 0.05, the null hypothesis is rejected. Hypothesis is rejected, and therefore the dice is biased. Then we will assume alternate hypothesis is true. So therefore the die is biased. So this is end of our example. Guys, I hope you like this video. Please like, share and subscribe, and thanks for watching.